Now we are going to start with the nitro group. So what is nitro group? First of all, I would like to tell you that nitro group is that whenever nitro group is particularly NO2. It is particularly NO2, and you know that we can obtain the aliphatic nitro compounds and also the aromatic nitro compounds. How? When the hydrogen of alkane is replaced by the nitro group, it becomes aliphatic nitro compound, and if the hydrogen of aromatic is replaced by the nitro group, it becomes an aliphatic or aromatic nitro compound. So that means you just have to replace the H, and by replacing H you can put NO2, and if you are taking the aliphatic chain, it will be aliphatic nitro compound, and if you are taking an aromatic compound already and you are replacing H from that, you are going to get the aromatic nitro compound. As far as the structure is concerned, so it is N double bond O single bond O, or you can write these are the resonating structures of NO2 actually. And if we talk about NO2, it is actually a ambidentate group. We know that actually what is that, in which the linkage can be from this side also as this also, and the linkage can be from O also. So if it is there from NO2, the structure is particularly like this, and if this linkage is through O, it is the structure is particularly like this, right. So that means it is an ambidentate group, it can link from the either side. Now if we talk about the aromatic nitro compounds, so actually aromatic nitro compounds are of two types, nucleus substituted and the side chain substituted. The nucleus substituted one is that in which that nitro group is directly attached to the benzene ring, like for example it is nitro benzene. Here suppose I have some other group and but NO2 is still there and it is directly attached to the ring, then it is particularly like this is the ortho position. So it is ortho nitro toluene. Why toluene? Because benzene with CH3 group is called as toluene. Likewise it can be side chain also. Suppose I have a compound like this, I have the benzene ring to which there is a linkage CH3NH2. It is particularly called as phenyl nitromethane. So it is attached as a side chain here and it is attached directly to the aromatic compound. Now as far as the IUPAC is concerned, suppose I have few structures, then how we write the IUPAC? It is going to behave as a secondary suffix. Suppose this is, it is going to be nitromethane. It is going to be nitroethane, it is going to be nitropropane, and similarly it is going to be like we are going to number it from this side, right, and we are going to get it that it is 2-methyl nitropropane. So this is how you are going to write the IUPAC. Now starting with the preparation, that how it is prepared. So basically it is prepared by two methods, one is from alkyl halide, other is from hydrocarbon. So how alkyl halide, suppose I need to take an alkyl halide and particularly it should be bromoalkane or it should be an iodoalkane because they are best suited for the preparation of the nitro compounds. We are going to react with AgNO2 and heat a little bit, and what we are going to get? We are going to get RNO2 plus AgX. In this reaction so it is again a nucleophilic substitution reaction. Along with this nitroalkane, we often get the nitritoalkane also. So, but here we can separate this nitritoalkane as its boiling point is comparatively very low as compared to the nitroalkane. So, by fractional distillation, we can easily separate it. So this is how we are going to prepare the nitro compound, that is the nitroalkane from this. But if we like to prepare nitrito, we can also prepare nitrito using the same thing, but instead of AgNO3 we need to use KNO2. So here we are going to get the nitrito compound, and along with that we get KX. So again a nucleophilic substitution reaction. In this this method is not best, it is not by this method we cannot prepare aryl halides, as we know aryl halides cannot undergo nucleophilic substitution reaction. So this is particularly a method used to prepare an aliphatic nitro compounds. Second is from hydrocarbon. So here what you are going to take, you are going to take an hydrocarbon, let's say anything, let's say methane or ethane, react it with HNO3. Keep the temperature approximately around 673 Kelvin. So you know that what is this NO2 group will just add up there, replace that H, and we are going to get particularly nitroethane. But if you take in higher ones, like suppose I take the propane, so there you take in fuming NH3, you take a fuming HNO3 and you get mixtures actually. So you know that what is the product, like if we carry out the this thing, the propane, like we are carrying out the nitration of the propane, what we get it? We get, particularly we get the nitropropane also, we get the isomer also, that means 2-nitropropane also we get, and we do get it also breaks up and we get the smaller ones also, we get the nitroethane also, and we get the methyl nitromethane also, and along with many oxidation products are also formed. Now this method is particularly not used for preparing, not best suited. As you can see that we are getting the mixtures. Here I am getting the nitropropane, here I am getting the 2-nitropropane, here it is breaking up also, we are getting the smaller alkane nitro compounds also. So that means this is not best method because the pure substance cannot be obtained by this method particularly, right. So these are the two famous methods, that is from the alkyl halide and from the hydrocarbon we can actually prepare a nitrogen compounds, that is the our aliphatic compounds, but here like by this method we cannot prepare the aromatic ones because they do not undergo the nucleophilic substitution reaction, right. So these are the preparations. Now we are going to start with the physical properties.